Hi, everyone. I want to start by talking a bit about the state of our security programs, specifically of using scanning tools. It feels like, is this as good as it gets? Like looking at a bunch of findings, most of them are false positives, non-relevant. And with all that work that we put in, we still find ourselves with security breaches. Embarrassing security breaches. Why? What are we missing here? So all those tools are operating under the assumptions that we are all the same, that we are all sort of clones, that we all write code the same way, we all use the same popular frameworks and libraries, and we all copy the same code snippets from Stack Overflow. And under this assumption, it makes sense to make a finite number of generic rules and scan all applications with those rules and find all the vulnerabilities, right? Well, no. Because we are still human, we are still unique, and until AI writes all of our code, we are still unique snowflakes with our own unique corporate bureaucracy that prevents us from making any changes, with our own unique code base. After all, that's why we have a unique app and product and not using just someone else's product. So what do companies do? They come up with their own rules, their own guidelines. For example, this library should be only used with a wrapper because it's not up to our security standards. Or this function is not totally secure, but we can't really change its functionality right now because some stuff depends on it. But like from now on, you should use it only like we have this safe version that from now on you should use for anything new. You should use this safe version of the function, and all those sorts of specific rules to the company. But so this kind of solves the problem of generic rules missing out on our problems, but it creates a new problem. Who enforces all those specific, unique rules? Who can even remember all of them? Like the developers need to check for that each code review, or does the security team needs to review the code like each time we make some changes? Like it doesn't make any sense, and it's just one big headache. And in this talk, I hope to give you some relief for this headache. So who am I? What's my motivation? My name is Michal Kamensky. I've been told to state it loud and clear, like some guy named Leroy Jenkins, if any of you ever heard of him. But that doesn't really help because no one can pronounce my name. Each time I go abroad, I'm like, Michael, Michelle, whatever. So I'm Michal. I'm a security researcher at Bound Security. It's a consultancy, not a vendor. I'm not selling you any products here. And we help companies to advance their application security programs. And when I just entered the security world, I was really fascinated by the fact that everyone wants to share their knowledge. Like, no matter if they're just starting out or if they are way into their career, they just want to share their knowledge with the community. So I was really inspired by that, and I helped initiate the project named Hackeriot, which helps women get into cybersecurity. I also helped organizing the B-Sides TLV in my country, and I enjoy giving back. So let's dive in. What's our mission here? It's to become omniscient. What does that mean? Well, Webster's dictionary defines it as having infinite awareness, understanding everything. We want to know everything that happens in our application, everything that happens in our code, all the problems that we have. We want to know everything, everywhere, all the time. So what does everything mean? We want to find all the problems that we have, all the custom problems, all the custom solutions we have. We want to know all of them. What does everywhere means? All across our code base, all across our application, all API endpoints. And what does all the time mean? It means every CI/CD run, each time we deploy new code, we want to verify again all our custom mechanisms. There are three types, generally, of vulnerabilities and mitigations. First, there are generic vulnerabilities, like SQL injection. And they have a standard fix. Just use the parameterized query. Then we have generic vulnerabilities that you can mitigate them with different options, like whatever that fits into your own application and your own flows and logic. And finally, there are app-specific vulnerabilities with bespoke mitigation, which means just something that has to do with your business logic. Like if you're selling stuff on your website, you don't want someone to be able to buy it for less than the price or whatever, like something that has to do with your application. So the first kind, generic vulnerabilities with generic solution, like SQL injection and parameterized query. This is exactly what generic scanning tools are good for. This is the first box. Generic SAST tool, and that scans the code statically, and the generic DAST tool that scans the application in runtime dynamically are built exactly for that. And there are a lot of tools that do exactly that. Yeah, a lot of tools. Okay. I probably forgot a bunch. So great. We have all those tools. They're scanning our code, finding our vulnerabilities. Perfect, right? Well, no, because we still have those two boxes. So what's the first box? Generic vulnerabilities with our own custom mitigation. Here we have a path traversal. The user is giving us input, and we just using it to give him the file that he asked for. We don't check the input that he gave us. We don't know where does he going on our server, and what file we're giving him back. So we come up. So here is an example of what you can send. You can just traverse the files and get to files that you shouldn't be getting to. And we propose some bespoke mitigation. We want to remove traversing up the files, and we just remove like the dots and slash. This isn't like a solution that I suggest you go and implement in your code. It's just something for the talk to understand the concept. But this is something that a generic tool will miss on. It won't know that we used this mitigation. And we will just get a bunch of false positives telling us we have this path traversal, and engineers will just get used to ignoring this finding. And then if they actually have a path traversal where we forgot to implement our mitigation, they will be just used to ignoring it. And our last type of vulnerability is the unique kind that is unique to our business logic. So for example, let's say we have coupons on our website, and like you can use the coupon to get a discount or whatever, and the mechanism it works on, the user gives a coupon code, it is checked in the database. If it's still valid, they get a discount, and then the coupon code gets erased from the database. But there could be a race condition here. And that's something that is really hard to find in static review of the code. Even the engineer that wrote the code will have a hard time finding that. And checking it dynamically with DAST will be difficult as well, because a generic tool won't know that we have this mechanism, won't know where to check, what to check. Like, it's too specific for a generic tool to find. So that was the everything. What are we looking for? Those two boxes of generic vulnerabilities with unique mitigations and unique vulnerabilities with unique mitigations. How do we do the everywhere? How do we check across our code bases, across our application? So for the static analysis part of this talk, I will be using SamGrep. You can use any kind of tool you want. I just use it for the demonstrations because it has a free open source version, which I'm using for the demonstrations. And it's easy to use, but there are a lot of alternatives. So what it basically does, it finds patterns in your code, but it's not just like doing Control F or grep or something. It has a semantic understanding of your code. So it understands flows, it understands like functions and classes and all of that. So that is what I'm going to be using for the everywhere. But what are we scanning exactly? So, story time. It's 2021. There is quarantine. COVID is out there. A group of tech bros are sitting in their apartment. They're really bored. Suddenly, one of them says, why won't we start a startup, develop an app that will teach cats to play chess? Great idea, right? Now, that might sound a bit weird to you, like who would invest in this sort of startup? But wait until you hear the name they came up with. Cyber AI Transponder Chess. What does that mean? I have no idea, but it has a lot of buzzwords. And it also spells out cat chess. Perfect. So this is our app. So we'll now look at 2 examples of static analysis. And just a disclaimer, those are just examples to understand the concept. It's not super sophisticated or anything, but you will understand and be able to apply it to your own applications with the sophistication levels that you need. So the first example, security decorators. Our problem is there are certain things on our app, for example, making the next move or declaring who is the winner, that needs authorization first. We need to make sure that our opponent cat doesn't make a move for us. So we have these sensitive functions that we need to check permissions first. And we want to have one function that does that and checks permission before each sensitive function. So we are creating a decorator, which is sort of a wrapper for a function that adds some functionality to that function, and apply those decorators to our sensitive functions. So here is the implementation of the decorator. It's in Python, and it's require update permission. And if the cat has permission to make the move, he gets it. If not, there is an error. And we have the class of sensitive functions. So for example, there is one function that we applied the decorator for updating the scoreboard. Okay, so what do we want to check here? We want to check that we didn't forget to apply the decorator in all the cases that require it. So here is the example code we're going to scan. We have the class of sensitive functions. We have the first function, update scoreboard, that has the decorator. And the second function for making the next move that doesn't have the decorator. So even though Simba won't be able to say that he won our tabby, he will be able to make a stupid move with his queen for him. So here is the layout of the rule. We have the pattern that we're looking for. We're looking for a function definition. We tell it to focus just on the first line of the name of the function because we don't need to find all the lines of the function definition. And we tell it that it shouldn't be inside this sort of pattern that has a decorator and then a function definition. And we only want to find things that are in the sensitive function class, because if it's not there, we don't need the decorator. OK, so when we run this rule on our code, we find only the case that doesn't have the decorator. It's easy, fast, and efficient. And Simba can't make this move for our tabby screen. OK, second example, a dangerous function. Say we want to ping our cat to make sure he didn't fall asleep in the middle of the game. So we send a ping and want to get a response. We don't want malicious inputs to be able to execute commands on our operating system. So we have this function that gets an input. We have the run ping function, and we get the input and put it into the run ping function, which is not really good to get user input and put it straight into a function that runs operating system commands. Here. So what we do is we create sanitization that sanitizes the input before it goes into the run ping function. So here is our sanitizing function. Here we have we get an input, and then we do run ping without sanitizing first. And here we sanitize first, and only then run the function. So how can we ensure that we didn't forget the sanitization somewhere in our code? This is our code. We want to find the first case that goes straight from get input to the run ping. And we don't want to find the second case that goes from get input to the run ping if it goes through the sanitizer first. So our source is the input. Our sink, where the input ends up and performs an action, is the run ping function. And our sanitizer is the sanitize function. And to find that, we're going to use taint mode, which is something that allows us to follow flows through our code. So we specify what our sources are, what's our sink, and we tell SemGrep to omit any findings that go through a sanitizer in the middle. And when we run this rule on our code, we get exactly that, only the case where we didn't go through the sanitizer. And our last example for static analysis. Let's say there is a library, a third-party library, we're using to unzip games of cats. It's called Pi7ZR. And it has a vulnerability now in this function, extract all. But we don't think we're using that. We're using other functions from this library. So it's Friday night. The developers don't want to update now. Like, we want to check, is it really urgent to update, or can we wait until next week? So how do we check for that? First, right now. And second, in the future, if we forgot to update because we're not actually using this function, we want to make sure someone didn't say, oh, we're already using this function. This library. Let's use another function from there, and it's the vulnerable function. So we want to verify it continuously, that no one using the vulnerable function as long as it didn't update. So here's our code. We have those two examples that we use extract all from the 7-zip library. And we have, this is the vulnerable function. And we have this other example where we use another function that's not vulnerable. We don't want to find that. That will be a false positive. Even though it's from the same library, it's not the vulnerable function. And finally, we have an example here where we're using extract all, which is the name of the vulnerable function, but it has nothing to do with the vulnerable library. So it will be a false positive as well. So this is our code. And why do we even need custom scanning here? Like, there are SCA tools that's supposed to find that. There are SAST tools. Like, why do we need that? So SAST tools generally don't get updated with CVEs. They don't look for that. They look for functions and stuff in our code, but they don't look for third-party libraries we're using. And SCA tools, which is their responsibility to look for vulnerable libraries we're using, they don't look if we're actually using the vulnerable function. Just check if we are using this dependency. So here is a rule. We are again using taint mode because we want to follow some flow from the 7-zip library into the vulnerable function. And when we run it on our code, we find only the first two cases that are the true positives, and we don't find extract all that doesn't come from the 7-zip library, and we don't find write all, which is a different function from the 7-zip library. That's for the static analysis. What about dynamic analysis? So the tool I will be using for the demonstration is called Nuclei. And it's open source, and it's free to use. There are no limitations on that. And it allows you to create custom rules to scan your application dynamically in runtime. And, well, yeah, I actually built this application. Okay, so here it is. The cats can play here. It's very nice. Yeah. So what do we want to check here? Okay, so, oops, that says 4, but it should be 3. We have 3 examples here. First is bad word checker, race condition, and SSRF. So what's the problem here? We don't want, the cats can specify their usernames, but we don't want any cats to offend their opponents and put really bad words that will make them hurt or offended or anything. For example, cucumber or dog or Roomba. Yeah, that's scary. So we want to make sure none of those words gets into the usernames. So we have a list of bad words. We have a regex that checks the input they give us and make sure the bad words don't come into the usernames. But what happens if we miss some combination? What if we forgot to check every API endpoint that they can send input to? So for example, if I want to put in, let's say, dog. Oh, you don't see it, sorry. Okay, so let's say we want to put in something like this. We shouldn't be able to do that, right? And if you put in something like this, or anything that has some delimiter in it. So let's say something like this. Okay, so this is, it does recognize that. So some symbols that we put into the username, it does recognize, some it doesn't. We want to check that and make a good list of everything we want. So we make a new create template, and we try to use the username Roomba and fuzz it with different symbols in the middle. And it found one symbol that we were able to put in. How it works? Sorry. Is basically we tell nuclei what method we want to use. And we have some payloads. Here I just used those 3, but you can give it a text file and it will run across all of them. And you just fuzz it in the query. There is just one parameter, and we tell it to infix. We can do replace or postfix or anything we want. And that's it. It uses this payload in order to fuzz. And it tells us it found a match if the response is username is valid. If it says username is invalid, we tell it negative true. So unless it tells us username is invalid, we found a problem. So this is the first example of fuzzing something we want to check on our application dynamically. The other case is a race condition. So we have a discount coupon on our application, and we want to check it can't be used more than once. We want to check the validity before we apply it and make sure it invalidates and no one can send concurrent requests and use it multiple times. So there is a possible problem of a race condition here. So let's try to run this game, this rule. 1 second. Okay, and we ran it. We ran 3 concurrent requests, and all of them worked. And now if we go on the app, we have 3 members here. I didn't do the whole registration and stuff, so it says undefined, but if the user was registered, so it would say it became a member 3 times. So there is a rest condition here. How did we check for that? So here's a template. We're using the post request for the validate coupon API endpoint. And you don't need to use a cookie. I just use this so it will be in the same session, but Nuclei does it automatically. And we specified a coupon code. And we told it that we want to execute a race condition 3 times. And if it returns OK, it means it worked. Let's just make sure that if we run it again, it won't work. It still works. Not quite sure why. Well, it's not supposed to, but oh, I'm sorry, I know why. It still returns OK, but it returns an error. So here it should check for an error. Sorry for that. But anyway, the point is, it executes, it sends concurrent requests with 1 byte missing, and then they all happen at the same time. And it checks for a race condition this way. This is something that a generic DAST won't be able to find because it doesn't know where we have problems, where to check for that, what kind of parameters to send. It's too specific, too unique. And if you know how to specify that, you can use Nuclei for specific endpoints with specific parameters that you want to check for a race condition. OK, and our last example is SSRF. We have the option to set a profile picture for a cat on the app, and it calls a URL on the web to set a picture. We could see it here. So if we say we have a male cat, it fetches for this image, or if we specify our cat is female, it fetches for this image. And those images are URLs on the web. So we don't want it to be exploited for an attacker to send for, to make the application call a different URL that they specify. So how do we mitigate that? We just whitelist the domains that we allow to access. And we want to make sure that across all of our relevant endpoints, we checked and really whitelisted domains. So what we're going to use is something that's called interact SH URL. It creates a random subdomain on .oast, and it checks whether our domain interacts, made a connection to this domain. So here is our template. This one takes a bit of time because the Wi-Fi here isn't the best, and it needs to actually make a connection and not just locally. And it works. Our domain actually made a connection to this domain. So a regular SSRF, some DASTs or most of them will be able to detect. But here we have a unique parameter that needs to be present, enable equals true. And it might be something more sophisticated than that. Like there needs to be some sort of flow before we can fetch a domain, or there are some parameters that are harder to guess. So a generic DAST won't be able to know, like, okay, I need to try for an SSRF here, but I need to put those specific parameters or do this specific flow before I try to do that. Like if there wasn't the extra parameter, a regular DAST probably would have found it. So that's a very simple nuclei template. Just the method get the URL we're interacting with, like our API endpoint with the parameter, and we want to match if the interact SH URL actually was contacted by our application. Okay, so we talked about everything. What are the problems we want to find? Generic vulnerabilities with unique solutions and unique vulnerabilities with unique solutions. We talked about how we do that everywhere, whether it's statically with unique rules that scan our code, or dynamically with templates that check our different API endpoints in runtime. How do we do that all the time? So we'll look just at the implementation of SemGrep, but it's easy to implement any of them, to integrate them into your CI/CD pipeline. On GitHub, you can use GitHub workflows, GitHub actions. You specify the trigger for the SemGrep rules to run every time code gets pushed into main. And you specify the rules you want to run. You can tell it to run only on specific files or folders, or run only a subset of the rules you have. You can specify that. And when you run this workflow, you find the findings. So, for example, here is an example of the second rule, run. And it tells us on what line we found the issue. And it also specifies all the flow. It tells us where the tainted data comes from, what it reaches, and through what does it go in the middle. And you can have different formats, text or serif or whatever. And you can look at all the findings in the security tab under code scanning and find all the findings and decide if you want to continue pushing or stop it and fix first. And you can go into the findings and see where it is in the code and what the problem is. So how do we enforce that all the time? We just integrate it into our CI process. There doesn't need to be any compilation or whatever. It just, when you push it into main, it just runs. And it gives you an alert, and you can decide if you want it to block the process or just alert you, but let the process go on. And that's it. So we've seen examples of specific rules for static analysis, for dynamic. But how do we start? How do we know what do we not want to analyze, what we want to automate? So we want to check for things that can be automated, that don't need someone, a human, to look at them and analyze them before to know that it's a finding. Stuff that we know, we need this authorization here, we don't want a race condition here, all those stuff can be automated. We want to focus on stuff that repeats itself. For example, we got a bug bounty report, we want to make sure it doesn't happen in some other place in our application. Or there is a finding with a generic SAST tool that happens in one place, we want to make sure it doesn't happen in other places. So that's also regression testing. And we integrate that into our pipeline and modify it along the way as we see the value we get from it and the noise we get from it. So it sounds a lot like QA, but after all, our security tests, it doesn't matter if it's for security vulnerabilities or code bugs. At the end, it's problems with our application. So the methodology can be quite similar. There are limitations to those tools, especially SemGrep. It has a limited cross-file scanning, like if there is a flow from a function in one file to a function in a different file, it doesn't support it in all languages. It won't find it in some of the languages. And also, it's free for, I think, up to 10 team members. If they're like more, they charge money for the tool. But we found that the free open source version is pretty good. But as I said, there are alternatives. I see more and more SaaS tools allow people to customize the rules, to write their own rules. So it's the same idea as I showed here. Also, there is CodeQL, which is free for open source software, but not for other software. And if you really hate your life, you can always use grep. But it just looks like my cat fell asleep on the keyboard. As for nuclei, there is Suite and ZTag proxy that are also possible alternatives. They're not quite exactly the same, but they also allow you to customize stuff and do dynamic testing. Okay, so what are key takeaways? We want to be able to check everything, everywhere, all the time. Everything, the vulnerabilities that don't have a generic solution. Everywhere, with simple rules that can scan all of our code base and all of our API endpoints. All the time, with a simple scan that just runs automatically with every CI run. That's it. So I hope you learned how to help your cats play chess securely. And that's it. Does anyone have any questions? which ones. The limitations?
Not actually, yeah, exactly. So did you also make tests on other like apps like this?
I did work a bit with checkmarks that allows you to customize queries, and no, that's the alternatives I tried. But like it really, it shouldn't really matter. The point is that it allows you to write queries, so use the tool that is simpler for you to use or for your team.
Okay, and another question regarding privacy, like what happens with the data or like what happens with the code if the app is
You're talking specifically about SamGraph? So you can download it and run it locally and you also, if you put it into your CI/CD pipeline, then you can add flags that tell it to not be sent to SamGraph cloud, and they have like privacy policy and everything on their website, so you can check it out. But yeah, you can also download it and run it locally on your computer. Any other questions? No? Okay. Thank you very much.